Yeah, hi Abhinay.
Hello, sir. Good evening. How are you?
Bus, all good. All good. I just thought
Oh,
whether class is there at 8:30 or 9 o'clock. So just reached home and saw that.
okay.
Monday, most probably I will not be able to join. I'm out of station.
Okay, no issue. Means directly will not start with the MLOps. We will take some problem statement, right? We'll do some
Sure.
feature engineering and all those things on some, and we'll first prepare a model. After that, we will try to push that particular thing into the server or the cloud, right?
Okay,
Means
okay.
everything we will do from the scratch, so there is no need to worry, right?
Right. No
So,
issue.
shall we now let everyone join, maybe if anyone who wants to join, right, then we can start.
Let's see.
Okay.
Okay, sure.
Yeah. I guess we can start, right? So I'm just sharing my screen. Okay. I hope
Okay.
my screen is visible, right, sir? My screen is visible, right?
Yeah, it's visible.
Okay. So, so we have discussed XGBoost, right? So we have seen the classification and the regression, both way, right? How your XGBoost basically works. Okay. So in today's class, what we will do now, we will do the coding part regarding these things. Okay. So I have taken this classification as a coding part, and one more thing I have taken the time series data. Why I have taken the time series data? Because this was something, a kind of unique thing we are going to do, right? So I have taken this a kind of one. We have the code over here, right? So I will show you that that how we can perform the time series things using the XGBoost framework, or you can say the library, right? And see, the first thing will start with the classification, right? So let me tell you means what we will do in the classification. Okay. So we have some sentences, right? Just like I love coffee, right? Okay, this is the one sentence. Maybe I can write Python is a great language. Python is a
क्या
great
मारा इसने?
language. Okay.
बताओ तुमको क्या
And
क्या करना है? बैठो.
maybe I can write machine learning is amazing. Okay.
क्या क्या करना
Machine
है दिखा
learning,
दो. कुछ डाउट है
machine
कोई पर?
learning is amazing. Okay. And maybe the next sentence could be coding is fun, right? So what we will try to do over here, we will do the kind of sentiment analysis. That's mean we will try to analyze whether this sentence is positive or negative, whether this sentence is positive or negative, whether this sentence is positive or negative, and whether this sentence is positive or negative. So this is also kind of classification task, right? So what we will do, we will prepare a data set, right? Only small data set, right? And we'll try to train the XGBoost, means using this XGBoost framework or the library, right? The complete model, okay? And once the model is trained, right? Once the model is trained, okay? So you know that once the model is trained, what we used to do, we will basically save our model,
How is a
okay?
variable different from variable
And
is?
once the model is,
नेपाली ने बोलने का बाद में बोलने का.
so your voice is, your, I guess,
Oh shit.
hello.
Yes, sir.
So can you just mute yourself?
Yeah, yeah,
Just,
sure.
yeah, thank you. So okay, so what we will do means, we'll first make a data set, right? So once we make our data set, as you know, we will try to break our data into X and Y, right? Means in the two part, okay? We will split our data set into training and the testing form, okay? So splitting will be done, right? After that, what we will do, we will fit our model, right? In between there will be some step, I will let you know, means how we can do those steps, right? After that, what we will do, we will save our model, right? We will try to save our model, okay? Once we are saved with the model, that means we will have one pkl file, right? Dot pickle file, okay? Once we are done with this thing, that okay, we have the model, so what we will do, we will give some input, right? We will give some input to this model, okay, to this .pkl model. Now this model will predict, sorry, this model will basically help you in the classification task, okay? So we will give the sentence and it will try to predict, or it will try to classify, we can say, right, whether the sentence is positive or negative, right? So this is our problem statement. The problem statement is that we have some the data set, okay, and this time your data set will be in the form of textual and the numerical, right? The textual will be your this text, okay, and the numerical will be, you will consist of whether it will be 1 or it will be 0. 1 mean your sentence is positive, 0 means your sentence is negative, right? Again we will have this sentence and this sentence, right? We will train our model using these data set and we will try to figure out when we will give the new sentence, right? Just like I am giving, debugging is frustrating, right? And we want to know whether this sentence is positive or negative, right? So this is the kind of classification task that we will perform using XGBoost framework, right? So this is our first kind of problem statement, okay? After that we will see the time series code, right? So what I will do now, I will try to code, right? So we'll import the pandas, right? As pd, import numpy as np, right? After that I will import XGBoost as xgb, right? After that I will import pickle. While I'm importing pickle, the reason being is that we will save our model, right? We will try to save our model, right? After
Yes,
that you will,
PKLD, right? Something. PKLD file, right?
yeah, exactly, pkl file, okay.
PKL. Okay.
Yeah. After that, what we will do, we will break our data set into X train and sorry, that to test and train, right? So for that, we know that we will use sklearn dot model underscore selection, right? Selection, okay. From here, what we will do, we will import test underscore, sorry, train underscore test underscore split, okay. So okay, so we will make our model. We will break our data set into train and the test part, right? And once we are done with the model making, so what we will do, we will just try to find out the accuracy also, right? So for that we will use the sklearn dot matrix. Okay, and import. So accuracy score we can import, right? Accuracy underscore score. Okay, so these are the some library that will be useful. Okay, we will run this cell. After that what we will do, we will make a data set, right? So I'm just writing over here data set for data set. Okay, data set having the textual, you can say the textual, and no, no, data set for sentiment. I can write sentiments analysis, a kind of sentiment analysis, positive or negative, right? So see, this is the data I am having. So the data, the textual data, just like I love programming, that is represented by label 1, right? That is, it is positive in nature. Python is a great for AI, right? You will find out that this is also kind of positive sentence, right? So it is also represented by 1. Okay, machine learning is amazing. This is also positive, represented by 1. I hate bugs in code, right? This is negative, that is represented by 0. Debugging is frustrating, right? This is also represented by 0. And coding is fun. This is also represented by 1 because it is a kind of positive sentence, right? So we have made small data, right? This is the only small data. And see, you can make this data very, very vast also, right? You can just, or you can just Google it, many sentiment analysis, the data set is present over there, right? You can use that data also. Okay, so let's suppose we are having this data. Okay, after that what we will do, we will make the data frame, right? So right, so this is our data frame. So we can just print also, right, whatever the data we are having. So see, this is the data, right? We are having one side text, one side label, right? This is your input. I love programming. Whatever the textual data you are having now, this will act as the input, right? And the label will act as the output, right? That means what we are trying to do, we will try to split our data into X and the Y, right? So we'll write the X underscore train, right? Comma, sorry, X underscore test, comma, I guess. Okay, right. So this is the thing. In the same thing, it will give you a kind of suggestion also, right? So X train, X text, Y train, Y test, train test split, where we are getting this thing from the model selection, right? From the sklearn model selection, import train test underscore split, right? And this is your first one. This is your second one, right? And we have taken the random test size is equal to zero point 0.2. That means the 20% for the testing and the 80% for the training, right? The random state in the sense that your data 42%, sorry, your 42 yeah, the 42% of your data will be static in nature, right? While it is doing the training part of your model, right? So once you are done with this thing, right, we'll try to run. After that what we will do, see, you know that this is the textual data, right? This is the textual data, this is the textual data, this is the textual data, right? So what we need to do, so maybe this thing I have not tell you vectorization and all those things. The reason being is that this is the topic of NLP and the deep learning, right? But we will use it little bit. The reason being is that we are focusing on this kind of problem, right? That will use the vectorization thing, right? So I will tell you means how we can do this thing. So what I'm trying to do now, what I'm trying to do, I will try to convert this sentence into numerical form, right? And whenever you convert any textual data into the numerical form, that process is known as vectorization, right? When you have the sentence, right? So what I will do, we will try to convert this every sentence into the vector, right? And we'll focus on those important words, right? Just like love programming, we will ignore I, right? Python, great AI, right? We'll ignore is and for. Python, machine learning, amazing, right? We'll ignore is, right? So whatever is, am, are, who, he, she, that does not make any kind of impact on the sentence. We will ignore all those words, right? So what I will do, mean for this thing, we will write the one variable that is known as vectorizer, right? So we'll import this tf idf. It is also kind of this is the vectorizer that we will use, right? After that, what we will do, we will try to vectorize our x train, right? We will try to vectorize our x train data because this is our x data, right? So we will vectorize first our train data, and after that we will vectorize our test data, right? So this is the vectorization. X train underscore vectorize is equal to vectorizer dot fit transform x train, right? In the same way we will do for the test also, right? So these things need to be done. Okay. Now the thing is that to use this function, right? Tf idf vectorizer. What we need to do, we need to import one more a kind of, you can say, the library, right? And that library we can import from the sklearn dot feature extraction. See, it is showing some kind of suggestion also, right? So we will use this suggestion, this first one, right? We will just delete this one, right? sklearn dot feature extraction dot text import tf idf vectorizer, right? And this will be used for the vectorization purpose, in the sense converting your textual data into the numerical, right? So we will run once more thing, one more time, okay? The complete thing. So this is also done, right? This is also done, right? We will split our data into x train x text, y train y test. We will do the vectorization also, right? And see, you can just see your data also, okay? So what we can do, we can just can show you, right? Okay, right now it is in the numpy. So okay, so what we need to do, see, we know that when we will do the vectorization, right? Whenever we do the vectorization, we know that this basically converted into the NumPy form, right? Now there is a kind of you can say the difference, right? Or you can say there is a kind of thing that we need to focus when we are dealing with the XGBoost. And what is the thing, that XGBoost uses the D matrix format for storing its or you can say whatever the input data it is having, right? Instead of using the NumPy, it is using the D matrix. D matrix is a kind of data structure used in the XGBoost. I will let you know, right? Just after I'm just writing this thing. So what I will do now, whatever the x train vectorized data we are having, whatever the x text vectorized data we are having, right? What I will do now, I will basically try to convert this data into the D matrix, right? Why? Because D matrix is the data structure used in the XGBoost, right? So we'll write over here D train, right? Equal to, and you can see over here it is giving you some kind of suggestion, xgb dot d matrix x train vectorized, right, comma label y train. D test is equal to xgb d matrix x text vectorized, comma label y test, right? So that means what it is doing now, this two lines are basically this first line. This first line is basically converting your y train data into D matrix form, right? From the numpy to D matrix. Just remember this thing. And for the second also, from the numpy to the D matrix. Why D matrix? Because D matrix is the data structure of our XGBoost algorithm, right? And why we are compulsory using this thing, the reason being is that now when we will use the D matrix, the calculation will be very fast as compared to the numpy, right? Just like we do the normalization in every step, so that the deep learning model can learn everything in a very good way, right? Everything will come into some range. So you can just consider through this concept also, right? So this thing we have to do, right? Once we vectorize our data, we will convert into D train. Okay, let me show you whether D train, right? So see, you can see over here, this is the xgboost.core D matrix, and it is stored at this address, right? So your this data is basically the kind of D matrix, and it is stored at this address. So this address is basically a kind of hexadecimal values, right? These are the hexadecimal values, and it is showing you the address, right? Whether this thing is stored. In the same way, you can check for this also, right? Now, what we have done now, we have the data set, we have converted our data into the forms of the vectors, right? And we have the D matrix form of our data, right? Now, what we will do, we will try to train our model, right? And you know that for training our model, what we need some we need some hyperparameter values, right? We need to define some kind of hyperparameter values. Okay, so just give me a second, right? So after that, what we will do, I will use one, you can say, dictionary, okay? And this dictionary will have some key value pair. And what are the key value pair? So see, we'll start with ETA, right? ETA is nothing but your learning rate that we have already seen in classification also, in regression also, right? N, okay? So let's suppose your ETA is 0.1. We are just defining this thing, right? You can use 0.3 also, unless you are doing the cross validation technique, right? After that, what we will do, I'm just writing the eval underscore matrix. So this will basically help you to find out the loss present in your model, right? And for this particular thing, what we will use now, log loss. So log is basically the kind of loss, right, present in the XGBoost. So means you can just find out this thing, right? So we'll write the log loss from here. Okay, log loss, right? After that, what we will do, we will try to write the that means what it is trying to do, right? So the objective will be the binary logistics. That means it will act as the binary classification, right? It will basically act as the binary classifier. So mean this complete model, right? This XGBoost algorithm will behave as the binary logistic. That means it will behave for the binary classification task, right? So this is the one thing, right? After that, you can just define the depth also. That means what is the depth of the decision tree, right? And we are defining this as the 3, right? See, when you will define this max to the more number, now at that situation the overfitting may also come, right? So for going on the safer side, it is decided, or it is advised that you just define the max depth in between 3 to 5, 3 to 7, and so on, right? If you will define less than 3, that will come the case of underfitting also, right? So see, these are nothing but these are some your parameters values in the forms of the dictionary, right? Key value, key value, key value pair. Okay, mean I hope till here everything is clear. Okay, so this is the this thing, right? Now what will be our next step? Our next step will be to train the model, right? And to train the model, we know that we will use these parameters, right? So what we will do, I am just making one a kind of variable, you can say, right? So I will write xgb dot train, right? Write the params comma your d train, right? Your num underscore boost, right, underscore round, and let's suppose 50. See what are these this term, this term is defined as the iteration, that how many times you will make your model. Just remember this thing, right? That how many times you will make your decision tree, right? So for the 50 times we will make this decision tree so that we can minimize our residual error, right? So this is the epochs value, right? After that, what we will do means, so okay, I'm just running this thing param dot, okay, okay, param, and we will train our model, right? The model training has been done, okay. After that, what we will do, we will try to save our model also, right? To save our model, we have already imported bst, right? Sorry, that pickle file, the bst dot save underscore model, okay. We can just write over here, means sentiment, right? So this will basically store our JSON data, right? Whatever we have. After that, with open whatever the vectorizer we are having, right? So we will open this thing, right? And after that, what we will do, we will try to store this thing, right? Mean we will try to store the this vectorizer.pkl file. Okay, so we have given this name, right? And see why we are using this thing now, why we are using or why we are storing this thing. I hope you remember the column transformer technique. Whenever you are giving some input data to the model, you need to pass that data through the feature engineering steps, right? All the engineering steps. That mean whenever I will give any new sentence for the sentiment analysis, I need to pass that particular sentence through this vectorizer.pkl so that it can convert into the numerical form, right? Into the numerical form itself. So that after that it can do the a kind of sentiment analysis or a kind of classification task, right? So for that particular thing, we have stored this vectorizer.pkl file, right? So this will be used in the input data, right? Whenever we will give some unknown input to the model, right? So our unknown input will first pass through this vectorizer.pkl so that it can convert into the numerical form from the textual data, right? So this is the one thing. Okay, once we are done with this thing, so okay, so this is your vectorizer model. And after that, what we will do now, we will save our main model. Main model in the sense, which will we do the prediction part, right? So with open, right? Vectorizer, okay. So vectorizer is already done. So what we can write over here, sorry. Okay, so loaded underscore BST is equal to XGB booster, right? Will load whatever the JSON file we are having, that, right? Whatever the JSON file or sentiment model, whatever we will make, right? After that, what we will do, we will try to save, right? So once we are done with this thing, we will try to open and we'll do the vectorization. Mean this one, right? We will load whatever the model we are having. Okay, so let me save this file. Okay, and see when you run this thing now, you will see the model over here, right? So this is the vectorizer.pkl, right? And this is your model.sentiment. Okay, let me show you this also. So see, you can see over here, right? The feature name, category, the law, the gradient booster, right? Everything is mentioned over here, right? Your split condition, your log loss, everything is basically mentioned over here, right? So you can just find out this sentiment underscore model.json file, right? And once you are done with this thing, we will again load our vectorizer.pkl file, right? Because this is a kind of important, right? So once we have loaded this thing now, once we have loaded this thing, okay, so what we will do, we will try to predict, right? See, our model making has been done. You can just see over here, right? We have taken the data, we have formed the data frame. After that, we have done the split of the data set, right? We have converted the data into the vectorization in the vectors form. After that, we have converted the your numpy into the d matrix. The reason we that d matrix is a kind of the data structure present in the XGBoost, right? After that, what we have done, we have trained the model, right? And we have stored with the vectorizer.pkl file with this name, right? And we have saved this model .json file also, right? So sorry, here we have saved, right? And here we have loaded, okay? And once we have loaded this thing, so we will open this file, okay? Now what we will do now, we will try to predict. Okay, I'm just making one function. So predict underscore text, okay? So we will pass some text over here, right? Right, after that, so okay, so I'm just writing text underscore tf idf is equal to, right? We will write the loaded vectorizer, okay? And after that, XGBoost. Okay, will convert into, again the prediction will be done. Okay, right. So till here it is clear, right? So see, here you will get some prediction in numerical form, right? So what we will do now means, once you get the prediction in the numerical form, right? So what we will do, we will try to write the base condition, right? If or else part. Okay. So see, it is showing you also, right? So okay, just let me write this thing in a very very simplified way, right? So I will take the first value over here, right? So I have just written this thing. If prediction is greater than zero point 0.5, that means your sentence is positive. If prediction is less than zero point 0.5, that means your sentence is negative, right? And after that, what we will do, we will try to write, okay, print. I will use the f string. So okay, okay, that is, I guess, enough. Okay, that is enough. So what we will do, I'm just running this thing also, right? And after that, what I will do now, I will just pass, or I will take the user input. Okay, let me take the user input. So user input is equal to, we'll take the text. Okay, and once we are done with taking the this user input, we will pass to this function. Okay, predict test text. Okay, so the same thing will occur. Okay, now it will ask me that to enter some text. So I'm just writing, uh, India is a great country, right? Okay, we'll try to predict whether the sentence is positive or negative, and see, it is predicted that the sentence is positive, right? A kind of classification has been done, right? Because we have the two classes, the positive and the negative class, right? So this is how basically you can use, and see, you can see over here that in a very very less data, how good the XGBoost is working very very well, right? And see, if you want to find out the accuracy also, right? So what you can do, so we can just use the accuracy also, right? Accuracy also, right? So you can just see over here, why predict is not defined. Why predict? Okay, I have saved with the other name, I guess. Let me check, just give me a second. Why predict? Why predict? Why predict? Why test? Okay, we have not done the prediction also. Okay, so mm, classification matrix can't handle the mix of binary and the continuous data. Okay, okay, okay. Just give me a second. Just give me a second. Why predict? Why predict? Why predict? So where we have BST. Okay, again it is giving you cannot handle the mix of binary and the continuous data. Why predict is equal to d test. D test value we are having over here. D test, D test, D test. This is the data. This is the train value. Okay. So we have converted into this thing. Mm-hmm. The classification matrix. The mix of 0, 1 target dot format type. Okay. Accuracy score the same thing. Why predict? Okay. 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 So we are having D test. X text vectorize X text data. Mm-hmm. Y predict, and this is your Y test. Okay, this will convert into. Mhm. But it is working well over here. Extrain, D test we are having over here. So we have used the retrain over here. Mm, okay. R2 value is coming around 0.00. Okay, so accuracy. Let me check the accuracy also. That what is the accuracy, right? So again, it is giving the error. Classification matrix cannot handle the binary and the. Okay, okay. Mm-hmm. Root mean square error. Mm. I guess that there is some issue with this accuracy terms. Maybe there is some kind of data conversion need to be done, or maybe something like that,
Yeah, right.
right? That is why it is not giving the this thing classification, the binary and the because I have converted into the D matrix, so maybe this is the main reason. Else it has shown this thing. Okay, so we'll just use this RMSC itself, right? I mean, this will also give you the error, right? Maybe around something 50% because we have the very less data, right? So we can just see this thing, okay? Because we are having very less data. So if we will have now this means just check the df.shape. So 6 comma 2, right? Only the 6 rows we are having, okay? So what we can do, we can increase the number of data set also, right? So maybe at that moment this thing, right? this thing will basically reduces, right, your RMSE value. Okay. And and see your prediction. See, right now what we have taken the threshold value of 0 point something, right, 0.5. Okay. So this is something very very less. So mostly what happen in the real life scenario, the threshold value is always taken above 75% or 70%, right? So that is why it is showing you the true. The reason being is that we have taken the very less threshold value, right? But the working is very very good, right? When you will increase the number of data set, definitely your threshold value will increase and your number of error will reduce, right? In this way you can just treat this thing, right? Means this is the complete means the complete cycle, basically how the XGBoost basically works, right? And here you need to just understand that whenever you are working the XGBoost, right, means so see, does not matter whether you have the textual data or not, you have to always convert your X-train and the y-test into the D matrix form, right? So this is the a kind of an important thing just to remember. Okay. So I hope this the code is clear, right? The kind of classification code for the sentiment analysis, you can say. Okay,
Yeah, clear.
right. So let me delete this thing. I guess something there is the issue with this. I have also not seen that how go with the accuracy part. Okay, walking after having dinner is good for health, right? So this is also kind of positive sentence, right? So means you can just check this thing. You can just write the while loop over here, right? Means so while true, so it will not terminate. Okay, and it will run again and again whenever you will mean give any grade, positive, right, bad. Okay, again giving the positive, right? The reason being is that it have the very very less data. Okay, so this is the main reason, but the actual working is the same, right? So we need to increase the data set. So what you can do now, you can just sentiment analysis data set. Okay, so we have the data set over here. You can get in Kaggle also, or in GitHub also you will find out the data set, right? So see, maybe this was the some topic. It was neutral, neutral, negative, positive, negative, positive. So they have created the three classes over here, right? Neutral, negative, and positive, right? So what we can do now, we can also improve this thing, right? We can add one more class over here, your negative, positive, and neutral, right? So a kind of thing, right? Okay. So this was with respect to the classification task. Okay. Now our what will be the next goal? So see, next goal is that I already told you that till now in machine learning we have seen the XGBoost, right? The only algorithm, right? That is something very very famous, right? Having some superior qualities, right? And we have seen that this algorithm is basically used for the time series, okay, data, right? You can use for any model making. Okay, right? So where you can see this time series thing, right? When you want to do some kind of stock prediction, right? In anything, or Bitcoin prediction. Mainly see, whenever if people talk about the time series data, they always talk about the this kind of project, stock price prediction, Bitcoin, or something, any kind of mean the thing which are comes under the category of time series, right? So maybe just like weather forecasting, right? This is also kind of time series data related, right? So all these things basically comes under this category, right? Time series data. And XGBoost basically give you the flexibility that you can also deal with the time series data along with the classification and the regression task, right? So in time series also we used to do the regression task only, right? We used to do predict something, okay, depends upon the previous data by doing the a kind of analysis over over that particular data, right? So what I'm trying to show you, so we have the Google stock. data, right? I have taken this Google stock data. Okay. Okay, let me just show you. Okay, so you can see over here. Okay, let me show you the data also. So you can get this data in Yahoo Finance. So Yahoo Finance is the very, very good website in which you can get any type of data, right? Or you can just log in into Yahoo Finance. Okay, so you can get means any company data over here, right? So so finance. Uh, Asia. Okay, just writing for Google. Okay, so I guess, I guess. This is not that one. Hmm. Okay, so you can see over here means to see we have the date, right? So we have the date over here, the one column. We have the open price, right? What was the highest price on that particular day, right? After that, we are having the lowest price also, and this is the clothing price, right? And we have one more price that is known as your adjusted close value, right? And next we have the volume, and we all know that this close value and the adjusted value is basically responsible for the prediction thing, right? Means whatever the small, I guess I don't have that much of knowledge, but as per my knowledge, this close value, right? This close value is very, very important, right? Along with that, open, high, and low are also very important to find out the medium value for the whole day, right? But this close value is also kind of important on what price this market has been closed and that particular day, right? So you can see over here, mean this in data set, right? So when you will realize, so we have the day, right? So we have the day, we have the month, we have the year. That means these are indicating your date, right? After that, we have the previous close value, right? And see, this is your rolling mean, right? You can just treat this at the adjusted, uh, your adjusted close value, right? And at last, what we have, okay, your previous, this is your rolling mean, this is your close value for the 5 window, right? Okay, so we have this data set, right? Now the thing is that, see, our task will be to give some input, right? And what will be the input? The input will be these, right? The input will be your day, your month, your year, your previous close value, and your rolling mean value, right? And it will basically tell you what was the closing value on that particular day, right? Of that particular stock. Means currently we are doing with the Google stock, so it will basically tell you for that only, right? So this is the kind of the time series data, right? So let me show you the data set we are having. Okay, so see, mean the same thing we will use, right? From the Yahoo Finance we are taking the data, right? From the Yahoo Finance. Okay, let me connect this thing. Okay, already connected. So I'm just deleting these files also, right? The reason being is that we will make the model. Okay, again we will make the two model, right? The one for the feature engineering, the second for your prediction part, right? So okay, so we have just erased this thing, right? So you can just see over here, right? Some libraries are there: XGBoost, Yahoo Finance, Matplotlib, sklearn, Square, and the Joblib, right? After that, what we will do, we will download our data set, right? So data from the Yahoo Finance for the Google company, and see, this is the data, right? From 2020 to 2024, 1 right? So this data we are having, right? And based upon this data, we will try to predict, right? We will try to predict, right? And this is
Abhinay,
your,
Abhinay, Abhinay, Abhinay. Just
yeah.
one thing, when you not download Google means we don't have to provide full www.google.com// something. By default, it will go to Google.
Yeah, no, no, by default it has downloaded the data from the Yahoo Finance. So see, this GOOGL, na, this is the I guess this is the tag for this finding out the Google. So let me show you also this thing. Okay. So when I will copy this thing now and I will paste over here, right? So you will see it is directly redirecting you to the Google, right? So this is the code means to download your data, right?
Okay, okay, okay.
See, you can just read over here also that using the Yahoo Finance library to download the historical data for the Google, and this is the keyword that the indication, right?
So
For the
from this
stock.
keyword, it will directly pull all
Exactly.
the data. Okay, okay, okay.
Exactly. And Yahoo Finance here, it is treated as na, this Y Finance is treated as the kind of library over here, this one, right? So let me show you
Okay.
mean this all. See this Yahoo Finance. See, this is the market download data from the Yahoo Finance. So you can just go download the market data from the Yahoo Finance API, right? So for that particular thing, we are using this library, Yahoo Finance. And on this particular library, we were having the n number of company, right? So Google is represented by GOOG, right? L, this. And this is the timeline from here to here, right? And after that, what we do now, let's suppose we are having this means this date, right? So see, this is the kind of feature engineering thing, if you will see, right? A kind of feature engineering is going on over here, right? So what we are doing now, we are just finding out the particular day, the particular month, the particular year, the previous close price, your rolling, right? These things. And if you have any value, just drop them, right? Okay, so this will act as your X data and this will act as your Y data. That is the main reason why we are doing this kind of feature engineering. Means to just separate your X data and just to separate your Y data, right? So these will act as your Y data. Sorry, these will act as your X data and this will act as your Y data, right? That is the prediction one. Okay. After that, see, once we are done with this thing now, again the same thing is going to happen, right? We'll convert our X train Y test, Y train Y test, right? And after that, we will fit our XGBoost, right? Okay, before fitting, what we will do, we will try to convert into D matrix, right? So you can just see over here, right? Okay. And see, once we are done with this thing, what we will do, we will just convert into D matrix. Okay. So once it is done, we will some define some parameters over here, right? So we are doing this time regression. This is squared error, right? Your matrix RMSE we are using max step 5 ETA point 1, right? And we have trained this model, right? Over 100 numbers, right? 100 epochs. That means ultimately you will make 100 decision trees, right? Which is having the depth of 5. Okay. I mean, this kind of intuition means should come by just looking at the this complete code, right? So once it is done, what we will do, we will try to predict, right? So this is your R2 value. That means coming around 95% is the accuracy, right? And this is your RMSE value. Okay. So what we will do now, we can just plot the graph also, right? With the actual prices and whatever your model have predicted, right? So a kind of visualization that you can do by using matplotlib library, right? So you can just see over here. Okay, mean whatever the model have predicted now, that is why it is showing you the accuracy of 95%. See, you can see over here, right? It is much more a kind of good result. You can just focus in this thing, right? Okay, so right, so this is the thing, right? Now the thing is that once you are done with this thing, now what we can do, we can save our model, right? So we have saved our model. Along with that, we have saved the features model also. Why we are saving the features model? The reason being is that now whenever we will get give some random input, right? So that random input need to be passed through this XGBoost feature so that it can convert into this way, right? In this way, right? Sorry, in this featured data, right? And after that, it will basically pass to our this model XGBoost, right? So we have saved this model, and you can just see over here, right? We have these two model. One will act as your features, and this will act as your time series, your main model, right? And these are something a quite important thing, right? And after that, what we will do, we will load both the model, right? And we will pass our data, right, for the prediction thing. Okay, so see, we have used the day 1 3 2025. This was your previous close value. This is your rolling mean, right? And it has passed all these data to your this one, right? Your predicted new function. And with the help of these two model, right? It has first featured everything, whatever you have passed. After that, it will pass those value to this particular model, right? And has predicted this thing, right? So this is your predicted price on this day, right? That means the clothing price will be this one something, right? Moreover, like this, right? So if you want to change, just like suppose uh 07, right? 3 means for March 2025, the clothing value was this one, right? Mm, okay, so it is coming around 145.98 something something. So see, we need to take the lots of data, right? So we have just taken, I guess, 20 to only 4 years of data, right? So we need to consider now for the time series data now. So see, there are many things, right? Some cycles are there in the time series data, right? So we need to consider those cycles also, right? And see, for dealing with the time series data, we have LSTM in deep learning, we have the RNN, right? We have ARIMA is also kind of algorithm. We have SARIMA, right? So Sarima basically see your seasonal cycles, right? Sometime what happen now, when winter, some stock price automatically goes down, right? So we need to consider those factor also. So these are some kind of algorithm that we need to just uh, use, right? But in terms of machine learning, your XGBoost will work in this way, right? All these are basically your deep learning part, right? So I hope this thing is also clear, right? How we can use the XGBoost in the time series data, right?
Yeah, yeah, clear.
Okay. So okay, and this was your classification, right? So let me see, binary log loss matrix evaluation. Okay, fine. Okay, right. So I guess we can conclude, right? Means from Monday onward now, what we will do, we'll try to means start with the MLOps, right?
Okay,
So, okay.
that will be great. Okay. Thank
Yeah.
you, sir.
Thank you.
Thank you very much.
Thank you so much.